My name is Brian McGee. I'm a master's student at the University of California at Davis, and I am interested in improving communication about metals distribution in groundwater to help us plan managed aquifer recharge. California has several tools to help you understand the distribution of metals in groundwater throughout the state. However, most of those are focused on deeper drinking water aquifers and won't necessarily provide the information we need to understand the distribution of metals that might be impacted by managed aquifer recharge projects. Here we see clusters of wells that show where arsenic has been sampled in groundwater in the Sacramento County, but it doesn't necessarily tell us what concentrations to expect in any specific area. And if we want to dig into the sources of the data, we can look at GeoTracker to understand the elements of the individual wells. But the files are divided up by counties across the state of California. And when you pursue the data set, what you find is that the data lives in this flat file, which is even more difficult to interpret. So we downloaded the data from GeoTracker for all 52 counties and imported it into RStudio so that we'd be able to look at the data by numerical distribution, but also a geographic distribution, and understand how outliers that may be the result of contamination are impacting the data. And because the data has spatial information attached to it, we can then use some tools built into R to understand the distribution of the samples and do an interpolation to predict what the concentrations might be in the areas where we don't have data. In this case, we used inverse distance weighting, and we used an optimizer to select the appropriate power for interpolating the data into the unknown areas. We also used GIS as we proceeded through the data analysis to help us visualize the data and better understand how we might target our analysis. Here you can see a plotting of the wells across the state of California that have arsenic data, and the color coding indicates the number of wells per county. We identified an area within the Central Valley of California, a four-county area of Sacramento, San Joaquin, Stanislaus, and Merced, that had a high number of wells that would be useful for this data analysis. Those four counties are located within the Sacramento and San Joaquin Sigma Basin and should have similar hydrologic and petrogenic properties, meaning that shallow arsenic should be similar in distribution. If we pull up a histogram of the raster with the interpolation on it, we can start to see the distribution of predicted concentrations for arsenic in shallow groundwater in the Sacramento and San Joaquin basins. We can see here that there's a central peak between 5 and 10 parts per billion that indicates the vast majority of the area of the basin. As we look at the interpolation of the Sacramento and San Joaquin Basin, we see a large degree of variability in the predicted concentration of arsenic in shallow groundwater. And as we look at the four county focus area, we see that same degree of variability with some significant predicted hotspots located within San Joaquin County. We're hoping that these methods will be used to help us better understand the distribution of metals in shallow groundwater and help planners in developing strategies for managing the potential displacement or interruption of those metals when they're planning managed aquifer recharge projects.